instructor at Oregon University, Ethiopia Higher Education. So in our 2 days classes, we are going to see about the two variable linear regression estimation method, especially using OLS estimating method. Therefore, before we're going to proceed to estimate about the two variable linear regression model, it is better to define what does mean the linear regression is, especially with the two variable. So, in case of this, we are going to estimate the two different variables relationship, and hence the effect of independent variables on dependent variable. That means, for example, if yi is equals to beta naught plus beta 1 x1 plus beta 2 x2 plus ui, this is our population regression function. But as per of the economics principles, we are not able to estimate overall the whole population values. Therefore, it is better to use what we call the sample regression function. So, let me, I say this is equation 1. So, this equation 1 has to be estimated in terms of the sample regression functions as yi is equals to beta naught hat plus beta 1 hat x1 plus beta 2 hat x2 plus ui hat. Then this estimated regression function is termed as what we call the sample regression function. And also let me say this is equation 2. So, while the case is 4, we are interested to use the sample regression function is overall to estimate about the population regression function. So, again, before we going to proceed to estimate about the values of parameters and also the like terms, it is better to remember what the econometric methodology is stated as. So, under the econometric methodology, we have 4 different methodologies that we call. As the first methodology, we have to specify our specific econometric model. The second one, after we specify our econometric model, it is better to estimate with the estimation, it is better to proceed to estimating our variables relationship within an application of the specified econometric model. As a third step, we can evaluate ourselves either the specified econometric model is goodness of fit or not goodness for fitting the model. And also, either it is good for fitting our objective or not, it has to be estimated and also evaluated. Finally, as a last stage, we have to forecast based on our finding that we call our analysis results. Therefore, in order to summarize this 4 different methodology of econometrics, it is better to take the numerical example. So, let us take the numerical examples. Example 1. Let me use the numerical data. Here I have a numerical data that we call the summation of x2 squared is equals to 3200. Again, the summation of x3 squared is equals to 7300. Again, let me say this one x1, and also let me say this is x2. The same is true again. The summation of yi is equals to 2000, not 2000, 8000. The same is true again. The summation of x3 yi is equals to 13,500. And also again, the summation of x2 is equals to 215. Again, the summation of yi the whole square is equals to 28,000. And also the summation of x, this is also again x2, this is also again x2. The same is true again, this is, let's say, x1 x2 is equals to 4,300. And also again, the summation of x1 y is equals to 8,400. And also the summation of x2 is equals to 400, while the overall sample size is 25. Then based on our these population values, we are tasked for computing the values for the sample regression, the values for the sample regression functions to generalize about the population regression functions, especially to analyzing about how the x1 and also x2 has effect on this yi that we call dependent variable. So, in case our general formula, what we have to use the coefficient for x1 and also x2 is we have to compute the values of beta 1 and also beta 2. Because by this coefficient, x1 and also x2's effects can be interpreted about the dependent values. So, as the first step, the beta 1 has estimated values. General formulas will be the summation of x2 squared times the summation of yi x1 minus the summation of x1 x2 the summation of yi x2 divided for the summation of x1 the whole square, the summation of x2 the whole square minus the summation of x1 x2 the whole square. The same is true again for beta 2. The general formula as the summation of x1 the whole square times the summation of yi x2 minus the summation of x1 x2 times the summation of yi x1 divided for the summation of x1 the whole square, the summation of x2 the whole square minus the summation of x1 x2 the whole square. So this is our general formula, how we can compute and also how we can generalize our population values by using the sample values. Therefore, the first method, what we have to compute here is we have to estimate and also we have to get our sample values. But these data are what we call the population value. So, again, in order to compute beta 1 and also beta 2, let me compute the values of Zoster, that we call the summation of x2, the summation of this one, and also of the rest. We have to compute them. So, let me, the summation of x2 I squared is equals to, what is the general formula we have to use? The summation of x2 the whole square minus n times x2 mean the whole square. So, the summation of x2 squared is the values what we have from here. The values what we have from here, especially this one. But here our n is the sample size, and also x2 is mean, but we have no x2 mean. So before we proceed to this one, we have to compute the values of x2 mean by using the summation of x2 divided by 4. So what is our summation of x2? Our summation of x2 is this one, 215 divided for n is 25. Therefore, x2 mean is equals to 10. Then the summation of x2 the whole square is equals to the summation of x2 the whole square minus n times x2 mean the whole square. So from our population data, x2 square means that 7,300 minus n is 25. X mean is 10, and also 10 the whole square means that, then 7,300 minus 2,500. So the difference between these values will be, let me use a mobile calculator here. So 7,300 minus 2,500, the differences will be, this is 100, and also this is 25. So the difference will be, what I mean here, 400, not 215. What is that? Yeah, x2 mean is, look, x2 is 400, so 400 divided for 25, this means that 400 divided for 25, our x2 mean is not 10, 16. So let me represent this one, 16, then let me take the difference of these two different values. 25, 16, the whole square times 25. The difference is 6,400. So 7,300 minus 6,400. The difference will be minus 7,300 minus 6,400. The difference will be 900. 900 is also again the summation of x to the whole square. This is one values. One we will going to use these values. So let me use this one, and also let me document it for the lab. So 900 is equals to the summation of x to I the whole square. The same is true again. We have to compute the values of yi, x1. So to get these values again, our general formula is the summation of yi x1 is equals to the summation of y x1 minus n times y mean times x1 mean. Look, the x1 mean is we have no x1 mean. The same is true again, we have no x2 mean. Therefore, before we're going to use this formula, it is better to compute the mean values of y and also x1. So y mean is equal to the summation of y over n. So from our population data, what's our summation of yi? Summation of yi means that this one, 800. So 800 divided for 25. Then let me use again mobile calculator. 800 divided for 25. The mean of y is equal to 32. The mean of y is 32. Then let me document it again. Laterally we can use it. X2 mean is equals to 16. Y mean is equals to 32. Then let me use this formula. What's our yi x1 from our population data? That is this one, 8,400. So 8,400 minus what's our n? 25. Again, what is our y mean? Y mean is 32 times what is our x1 mean? Again, we have no x1 mean. So to get x1 mean, the formula what you have to use is the summation of x1 over n. So from our population data, our x1 is look, where is our x1? Where is our x1? That is what I miss here. Let me I use the values of x1. The values of x1. It is 250. This one, what I mean. This one. So 215 divided for n is 25. Then x1 mean is equals to 10. So let me again document it. X1 mean is equals to 10. And also let me use here 10. So let I use this by using mobile calculator. So 32 times 25 times 10, 8,000. Then 8,400 minus 8,000, the difference will be 400. So 400 is the values of our yi x1. So just we get the critical point for these values. So let me document it again. Finally, we will use it. x1 equals to 400. The same is true again. We have to compute the values of the summation of x1 and also x2 from the population data. So let me use this space to compute the summation of x1 and also x2 for the sample values. For that case, look, the summation of x1, x2 is equals to the summation of x1, x2 minus n times x1 mean times x2 mean. Look, x1 mean is what we have here, 10. The same is true again, x2 mean is what we have here, 16. Then the summation of x1, x2 from the population data is this term, 4,300 minus n is 25, x1 is 10, and also x2 is 16. Again, let me use the mobile calculator. So, 25 times 10 times 16 is equal to 4,000. 4,000. So the difference between this one is 300. 300 is the value of what? x1, x2. So again, we compute here and also getting the values of the summation of x1, x2 for the sample. Therefore, let me again adopt the summation of x1, x2 is equal to 300. Again, we have to compute the values of this term. The values of this term. That means the values of this term means that look, the summation of yi x2 is equal to the summation of y I x2 minus n times y mean times x2 mean. This means that look, from our computed previous, we have x q mean and also y mean. So the summation of these values are from the population what we have here. So what's our yi x2? yi x2 from this term is this one. So 13,500 minus our n is 25 times y mean is we have 32. Again, x2 mean is what we have here, what we got 16. So again, let me use the mobile calculator here to get the difference values between this term. So 25 times 32 times 16. Then the difference is the summation, the product values will be 12,800. So the difference is 500, 700. 700 is equal to the values of yi x2. So this is also again computed for these values. And also let me document it here, the summation of yi x2 is equal to 700. Because finally we will use in terms of the general formulas of beta 1 and also beta 2 to get the values of each parameter. Again, next we have to compute the values of this one. The summation of x1 the whole square and also the summation of x2 the whole square has to be what? Computed. So let me proceed to them. To get the values. So the summation of x1 the whole square is equal to the summation of x2 x1 the whole square minus n times x1 mean the whole square. So look, our x1 the whole square is this one, 3,200. So 3,200 minus our n is 25 times our x1 mean is what we have here 10. So 10 the whole square. This means that 3,200 minus 25 times 100. This means that 3,200 minus 2,500, the difference will be 700. So 700 is the summation of x1 is the whole square. This is also again computed and also our values for this term. So let me again I document this. So the summation of x1 the whole square is equal to 700. Again, finally, we are starting to compute the values of the summation of x2 the whole square. So let me compute the values of the summation of x2 the whole square by using its general formula as the summation of x2 the whole square minus n times x2 mean the whole square. This will be look, regression data, x to the whole square. This was 7,300 minus what's our n? Our n is the number of sample size, 25. Times what's our x2 mean? X2 mean is 16. So 60 is the whole square. Again, let me use the mobile calculator to get the values of this term. So log 16 square of 2 times 25. This is it will be totally 7,300 minus 6,400. So the difference between these two different terms is, let me, 7,300, 900. So 900 is the value for what? X to the whole square. Again, finally we complete here and also we give the value of the summation of x to the whole square for the sample values. So let me document the summation of x to the whole square equals to 900. This is these all are at the first step what you have to compute in order to estimate the values of each parameter, like beta 1 and also beta 2. As a second step, simply we have to use this general formula based on our sample data. So let me proceed to the second step. As a second step, look, let me compute the values of each parameter, like beta 1 hat by using the general formulas of the summation of x to the whole square times the summation of yi x1 minus the summation of x1 x2 times the summation of yi x2 divided for the summation of x1 the whole square, the summation of x2 the whole square minus the summation of x1 x2 the whole square. So look, what are the values for the summation of x2 the whole square from our documentation? 900. 900 times what is the summation of yi x1? Yi x1 it means that yi x1 400 minus the summation of x1 x2. What is 300? 300 times the summation of yi x2. So the summation of yi x2 from our sample data is 700, then divided for the summation of x1 the whole square. The summation of x1 the whole square is 700 times the summation of x2 the whole square. That we have 900 minus, look, the summation of x1, x2 the whole square. We have to take the square values of the summation of x1 and also x2. So our x1, x2 is 300, then we are attached to the square value of this term. Therefore, let me use again the mobile calculator here. 900 times 400. This is 360000 minus this one is 210 divided for this product will be 63000 minus the square value of this 300 is 19,000. So let me take the ratio of these two terms. 2100 equals to 115,000 divided for the difference between 63 and also 90 is, I think, 514,000. So let me take the ratio of these two terms divided for 54000. So the value of this is will be 0.277 equals to the value of the first parameter that we call beta 1. This is our final result for the first parameter that we call beta 1. Again, next we have to compute the values for the second parameter that we call beta 2. So beta 2 hat is equals to the summation of x1I the whole square times the summation of yi x1 minus x2 minus the summation of x1 x2 times the summation of yi x1 divided for the summation of x1 the whole square, the summation of x2 the whole square minus the summation of x1 x2's whole square. This is the general formula what we have to use to get the second parameter that we call beta 2 hat. So let me use the values what we have for each term, like the summation of x1 square. What we have the values are from our computed values 700 times the summation of yi x2 is 700 also again minus the values of the summation of x1 x2 that is 300 times the summation of yi x1 that is equal to 400 divided for what is our summation of x1 the whole square, that is 700, that's 700 times the summation of x2 the whole square, that is what we have 900 minus the summation of x1 x2 the whole square. It means that we have to take the square values of 300. Then let me we use this space. So 7 times 7, 49 something, minus 3 times 4, 12, divided for 7 times 9, 66, minus 300 the whole square, it means that 19,000. So let me use here mobile calculator to get this ratio. So 49 minus 120, the difference of these two terms are 3017, this one, and also again the difference between this is 5400. So let me again use mobile calculator here. The ratio of these two terms is 0.68 is equal to the values of the second parameter that we call beta 2. Look, based on the assumptions of ordinary least square, the values of each parameter has to be ranged between 0 and also 1. This means that it never be beyond than 1 and also it never be less than 0, what it means negative. For that case, the assumption is here it is justified 100%. Because our beta 1 is what's our beta 1? Our beta 1 is computed 0. Our beta 1 is equal to 0.277. This is greater than 0 and also less than 1. The same is true again. Our beta 2 hat is 0.6. This is also again less than 1 but greater than 0. Therefore, 100% the assumptions of OLS is justified. Next, here after we compute the values of each parameter, we may be tasked for computing the variance of these two different terms that we call the variance of beta 1 and also beta 2. So, to compute the variance of beta 1 hat, the general formulas that we have to use here is, look, the sigma hat square times the summation of x2 the whole square divided for the summation of x1 the whole square, the summation of x2 the whole square minus the summation of x1 x2's the whole square. This is what the general formula has to be used to get the critical point for the variance of beta 1. Look, from our sample data, we have the values of the summation of x2 square and also the other terms. But what we have no value is, we have no values for the sigma hat. We have no values for the sigma hat. Therefore, it is better to compute at the first step. For this step, getting the values of sigma, by using this general formula. So to compute the values of sigma, our general formula is by using the summation of ui hat the whole square divided for n minus k. When n is needed for our sample size, k is needed for the number of parameters, and also ui is the summation of error. So look, our number of sample size is 25, that's obvious based on our given data. The number of parameters is also again obvious. We have two different parameters, beta 1 and also beta 2, but what we have no value is the values of ui hat is also again under the equation. For that matter, we have to compute the values of the error term first of all, before we go into compute the values of the sigma. So, by using the general formula to get the summation of ui hat square, the error term square, we have to use the general formula as yi the whole square minus the summation of yi hat the whole square. Look again. This value is the same with what we have from our population data. If you remember that, and also from our given data, the summation of yi the whole square from the population data is 28,000. So here what it means is 28,000 minus the values of the summation of yi hat square. Still, we have no these values. For that case, again, we have to compute the values of yi hat square by using the general formula as look, beta 1 hat times the summation of x1 y I plus beta 2 hat times the summation of x2 yi. Look, our beta 1 is 0.277. Our summation of x1 yi is what we have the data from the computed values saying 400 plus our beta 2 is 0.68 times the summation of x2 yi. That is the same to that of 700 what we have from the computed values. So we have to take the product of this term. And also finally, it will be the values of the summation of what I had the whole square. So let me use the mobile calculator here again. 77 times 400. This is 110.8 plus this is again let me use 0.68 times 700. This will be 476. And also the product of these two terms are 0.2. This will be not 0.2. 0.8. The product of these terms is 586.8. This is our value for what? The summation of what I have the whole square. Let me say this is equation 1. Let me say this is equation 1, and also this is the values for our summation of what I have the whole square is equal to 586.8. Again, let me compute the values of the summation of the error term. The summation of the error term has to be what? Computed for this term. Therefore, let me proceed to that. So, the error term I square is equal to the summation of what the general formula we have is the summation of yi the whole square minus the summation of yi hat the whole square. Look, our summation of yi the whole square is from our population data. It was 28,000 what we have, and also the summation of yi hat square is equal to 586.8. So the difference between these two different values will be the values of our error. summation of our irritant. So let I take this mobile calculator to use the difference to find the difference between these two terms. Minus 586.8. The difference is 27,413.2. This is our values for this time. That we call the summation of irritant. Therefore, let me I open it like this. The summation of ui r squared is equal to 27,413.2. Just let I say this is the values of the irritant, and also let I say this is equation 2. Again, for the second task, for the next task, what we have to compute is we have to get the sigma values. The sigma values by using what? The summation of the irritant, the summation of irritant r squared minus n minus k. So what is our irritant square? The values will be the values from our computed values is 27,413.2 divided for what's our n? What it means? Our sample size is 25. The number of our parameter k, that is 2. So this means that 27,413.2 divided for 23. Then finally, the ratio of these two terms is the values of our sigma square. So let me use mobile calculators to get the ratio of these two different numbers. Divided for 23. So our sigma hat square is equal to 1,191,878. This is our sigma hat square. But our final objective is not to get the sigma hat square, rather than to get the values of the variance for beta. Therefore, let me say this is equation 3. Let me say this is equation 3. Then the variance of beta 1 hat is computed as the sigma hat square times the summation of x2i the whole square divided for the summation of x1 the whole square, the summation of x2 the whole square minus the summation of x1, x2's the whole square. Then our sigma value is this one. Simply what we have to do is simply substituting our values. So 1,191.878 times our summation of x2 the whole square is 900 divided for the summation of x1i the whole square, that is what we have 700 again, times the summation of x2 the square is 900 minus the summation of x1 and also x2 is 300. Therefore, we have to take the square values. So look, let me again I use mobile calculators to get the product of these two terms. So 91.878 times 900. Then the value of this is 0.690.2 divided for 7 times 9, 63. So we have these values. And also the square value of this is 19,000. So let me again I use the difference between these ratios by using mobile calculator as 0.72690.2 divided for 54. Then let me I use the ratio of these two numbers. So 1,072,690.2 divided for 5400. Then the ratio of this will be 1.986 is equal to the variance of our first parameter that we call beta 1. This is our final result. So this is the variance of beta 1 is 1.986. So this is, let me document it again. Variance of beta 1 hat is equal to 1.986. Again, the second task, what we have to do is we have to compute the values of the variance for the second parameter, like beta 2. Variance of beta 2 hat is equal to, variance of beta 2 hat is equal to sigma hat square times the summation of x1 the whole square divided for the summation of x1 square, the summation of x2 square minus the summation of x1, x2 the whole square. So look, our sigma is still similar with what we have the sigma value from our previous computer. So our sigma is 1191.9878 times our summation of x1 the whole square is 700 divided for the summation of x1 the whole square, it means that 700. The summation of x2 the whole square, it means that 900 minus the summation of x1, x2 is 300, therefore we have to take the square values. So again, let me use mobile calculator here to get the ratio of these two different numbers. So 1191.878 times 700 is equal to 834.314.6 divided for 54 these values, because this is similar with this one. So 54 is constant for both. Therefore, let me again use mobile calculator to get the ratio of these two different products. So this will be 1.545 is equal to the variance of our second parameter, like beta 2. This is a full response for beta 2's variance, and also this one is a full response for beta, this is for beta 1, and also this is for beta 2. So this is a full response, and also let me again document this. Variance of beta 2 hat is equal to 1.545. Again, we may be taxed for again after we compute the variance of beta. Just let me compute the covariance of these two terms. That we call the two parameters. Beta 1 and also beta 2's covariance has to be computed. Therefore, let me compute. So, covariance of beta 1 and also beta 2 is computed as the negative sign of the sigma hat square times the summation of x1, x2 divided for the summation of x1 the whole square, the summation of x2 the whole square, minus the summation of x1, x2's the whole square. This is the general formula what we have to use to get the covariance between beta 1 and also beta 2. Look, our sigma value is similar with this one, but the difference is we have to add the coefficient in terms of the negative sign. Therefore, look, the negative values of 1191 points. What our sigma values? Our sigma value is, where is that? 1.878 times the summation of these two terms, the summation of x1, x2, that we call 300, divided for the summation of x1 the whole square, it means that 700 times the summation of x2, the whole square means that 900 minus x1, x2's product is 300. We have to take the square values. Look. So let me I use again the mobile calculator here. The mobile calculator here. 1191.878 times 300. Then the product of these two terms are 63.4 divided for 54. Still, this one is constant because it is similar with these values. So let me I take the ratio of these two numbers. Divided for 54000. So this is negative. This is the negative values, and also this will be negative 0.66 is equal to the covariance of beta 1 half and also beta 2 half. This is the full response for the question which we are asking for the covariance of beta 1 and also beta 2. So let me I document this one here. The covariance of beta 1 and also beta 2 half is equal to negative 0.66. This is our covariance values. Then after you compute the values of the covariance, we may tax it for computing the coefficient of determination. So let me proceed to compute the values of the coefficient of determination. So here the coefficient of determination, it means that we have to tax it for computing the values of the R square and also adjusted R square. So let me compute first for the R square that we call, and also by using its general formula as 1 minus 1 minus sorry. Before you're going to compute the values of the coefficient of determinations, let me compute the values of standard error for both. So standard error 2, standard error 2, beta 1, and also beta 2 has to be computed. Therefore, standard error of beta 1 hat is similar with taking the radical values of the variance of beta 1. Do you see? We have to put the variance of beta 1 under the radical. Then after our values is standard error values for the first parameter like beta 1. So let me take the radical, puts under the radical the variance of beta 1. So our variance for beta 1 is 1.986. So let me use here mobile calculator again. So the radical values of 1.986 is equal to 1.409 is equal to the standard error of beta 1 has. This is the full response for standard values of beta 1. The same is true again for computing the standard error for beta 2. We have to put under radical the variance of beta 2 has. So let me put it. The variance for beta 2 is what we have, 1.545. Then let me again use here mobile calculator. 1.545. Then our final result will be 1.24. This is equal to the standard error of beta. This is what we have, the values for standard error for beta 1 and also beta 2, and also this is 100%, the full response for the aspiration. So let me document this one first. So standard error of beta 1 half is equal to 1.4, and also standard error of beta 2 half is equal to the coefficient of determination, it means that the R square has to be computed. So let me use the general formula for for the R square. So the general formula for R square is the summation of yi hat the whole square divided for the summation of yi the whole square. Look, this is what we have from our beginning computed values. This means that directly it is equal with the beta 1 hat the summation of x1 yi plus beta 2 hat times the summation of x2 yi divided for the summation of yi is the whole square. So from our first computed values, the values of this term is equal with 586.8. And also again, the value of this is from the given population data, we have 28,000. 28,000. So let me take the ratio of these two numbers. The ratio of these two numbers. So 586.8 divided for 28,000. This is equal to 0.0209 equals to the values of our R square. The values of R square. This is the full response for the question which we may be asking for computing the coefficient of determination. So let me document this one again here. Let me document it. R square is equal to 0.0209. This is our R square values. For the second, after we compute the R square, if the firm or if the economic agents have two different parents, the first one, parent 1, let me say R square, and also the second parent, and also the parent which needs the readjustment for the firm, we have to compute the values of adjusted R square. Because our final objective is to say the progressive of the production activity by the economic agent is it is better within the first parent or within the second parent. So to generalize this one, let me compute the adjusted R square. So to compute the adjusted R square, our general formula is 1 minus R square divided for n minus 1 divided for n minus k. This is our general formula, what we have to use to get the adjusted R square. For that case, look, our R square is computed here, and also we have 0.0209. N is sample size, what we have 25. K is our number of parameters 2. Then simply we have to put this. So let me use this space again. So R square adjusted R square is equal to 1 minus R square divided for n minus 1 overall n minus k. It means 1 is constant here, 1 minus our R square is 0.0209 divided for our n is 25 minus 1 divided for our n is also again 25, our k is 2, then this will be 1 minus 0.0 something between that, look, minus 1 is equals to 0.979 divided for 24 over 23, what it means. For this, let me use again a mobile scientific calculator. Here, 1 minus 0.979 is equals to 0.021 divided for 24 over 23. Then this will be look again 0.021 the value for 24. This is 0.000875 over 23. Then this is finally our adjusted R square is equal with 3.804. This is what we call the second production progress for the field after the readjustment as per of the recommended from the economic experts. So let me document this one, and also finally let me going to generalize our adjustments and also before an adjustment for the field. So let me document here the R adjusted values 3.804. For this, based on our R square and also adjusted R square, we can generalize that the recommended for the field from the economic expertise for the readjustment to the particular economic progress, the second period is better than the first period. This is our final conclusion. Then, after we compute this coefficient of determinations, we may be tasked to compute the values of or to test the developed hypothesis. In case either the null hypothesis is going to be accepted or failed to be accepted has to be what? Tested as per of economic principle by using each respective formula for each parameter. For that case, let me solve the t calculated for beta 1 by using as look beta 1 hat divided for the standard error of beta 1 hat. So our beta 1 hat is look again from our previous computed values. We have 0.277 divided for our standard error of beta 1. It means that we have to take the variance of beta 1 hat. Indirectly what it means. But we have actually the values of the standard error of beta 1. Therefore, simply let me substitute 0.277 divided for standard error of beta 1 is 1.407. Then let me not 07, 09. Let me use here mobile calculator. 0.2 0.277 divided for 1.409. So our value is 0.196 is equal to the t calculated for beta 1. The same is true again. We have to compute the values of t calculated for second parameter beta 2 by using beta 2 hat divided for the standard error of beta 2 hat. So look, our beta 2 hat is what we have 0.68 divided for standard error of beta 2 is what we have 1.24. Therefore, let me use here mobile calculator again to get the ratio of these two different values. 0.68 divided for 1.24. So our value is 0.548 is equal to the t calculated for the second parameter that we call beta 2. Look, why the reason for we are interested to compute the t calculated for beta 1 and also the t calculated for beta 2 is to say something based on the acceptability of null hypothesis and also the failed to be acceptability of the null hypothesis. So our criteria is look, the first one is this one has to be computed, and also the second criteria is we have to use the t statistical table. In case based on our t statistical table, look, and let me say at alpha values 5%, at alpha values 5%, the t tabulated for beta 1 and beta 2 is log is equals to 1.714. So, by comparing the t calculated for each parameter and also the t tabulated for each parameter, the criteria is if t tabulated is greater than the t calculated, the conclusion will be the null hypothesis is fail to be rejected, and alternative hypothesis is rejected, and also the vice versa is also true. For that case, based on this criteria, look, let me see for each parameter. The t calculated for beta 1 is 0.19, the t tabulated is 1.71. Therefore, the t tabulated is greater than t calculated, and also based on the first parameter, the null hypothesis is failed to be rejected. Again, let me proceed for the second parameter. 0.54 is the t calculated for beta 2, the t tabulated is still constant. For that case, for both parameters, the null hypothesis is failed to be rejected, and also the alternative hypothesis has to be rejected. This is a conclusion. Finally, we have to test the values of f statistical to test either the specified economic model is good for fitting the model or not fitting the model has to be computed. So these are what we have to see in our today's classes. If you have comments, suggestions, and also the questions, you can contact me by using my email address. By using this one, 0.9340247@gmail.com. So I hope good luck for all of you. Thank you for your attention. Thank you so much.